Welcome to video 3 for this unit on linear equations and linear systems. In this video, we're going to focus on equations with different numbers of solutions. An equation is a statement that two expressions have an equal value. The equation 2x equals 6 is a true statement if x is 3, because 2 times 3 equals 6 is true. It is a false statement if x is 4, because 2 times 4 equals 6 is not true. The equation 2x equals 6 has one and only one solution, because there is only one number, 3, that you can double to get 6. Some equations are true no matter what the value of the variable is. For example, 2x equals x plus x is always true, because if you double a number, that will always be the same as adding the number to itself. Equations like 2x equals x plus x have an infinite number of solutions. We say it is true for all values of x. Some equations have no solutions. For example, x equals x plus 1 has no solutions, because no matter what the value of x is, it can't equal 1 more than itself. When we solve an equation, we are looking for the values of the variable that make the equation true. When we try to solve the equation, we make allowable moves assuming it has a solution. Sometimes we make allowable moves and get an equation like this. 7 equals 8. This statement is false, so it must be that the original equation had no solution at all. Sometimes it's possible to look at the structure of an equation and tell if it has infinitely many solutions or no solutions. For example, look at 2 times the quantity 12x plus 18 plus 6 equals 18x plus 6 times the quantity x plus 7. Using the distributive property on the left and right sides, we get 24x plus 36 plus 6 equals 18x plus 6x plus 42. From here, collecting like terms gives us 24x plus 42 equals 24x plus 42. Looking at these two expressions, we can see the coefficient of x on each side is the same number, 24, and the constant term on each side is the same number, 42. A coefficient is a number that is multiplied by a variable. A constant term is a term that doesn't change when the variable changes. Since the left and right sides of the equation are the same, we know that this equation is true for any value of x without doing any more moves. We can sometimes use structure to tell if an equation has no solutions. For example, look at 6 times the quantity 6x plus 5 equals 12 times the quantity 3x plus 2 plus 12. If we think about each move as we go, we can stop when we realize there is no solution. First, we can multiply each side by 1/6. This leaves us with only 6x plus 5 on the left side, and distributing 1/6 on the right side leaves us with 2 times the quantity 3x plus 2 plus 2. Now we can distribute 2 on the right side. This last move makes it clear that the constant term on each side, 5 and 4 plus 2, are not the same. Since adding 5 to an amount is always less than adding 4 plus 2 to that same amount, we know there are no solutions. Doing moves to keep an equation balanced is a powerful part of solving equations, but thinking about what the structure of the equation tells us about the solutions is just as important. Thank you for watching video 3 of 5 for this unit on linear equations and linear systems.